Hi, and welcome to the second video for section 8.1, the section on polar coordinates. So in this section we're going to start dealing with conversions from our rectangular coordinate system to polar coordinates, or polar back to rectangle. So first thing we need is the relationship between polar and rectangular coordinates. So this you're going to want on your cheat sheet, this formulation. So first is polar going to rectangular. So if we're given polar coordinates, so we're given a value of r, we're given a value of theta, but we want to know how does that relate to an x value and a y value in the rectangular coordinate system. Well, x is equal to r times cosine of theta, and y is equal to r times sine of theta. That one's not too bad. It gets a little more difficult when we're going from rectangular to polar. In this situation, my r squared is going to be my x squared plus y squared. It's like the Pythagorean theorem, right? So if I have my rectangular coordinate system and I have some point out here, well, this would be my r. But how do I find that? Well, it's this value of x and this value of y. Pythagorean theorem, square the x, square the y, that gives me my value of r squared. If I'm trying to go from coordinate system to rectangular system, I have that theta in there. Well, how do I figure out theta? Well, using my trig functions. What is theta? It's tangent of y over x. So tangent of theta is equal to y over x. Obviously x can't be 0 because it'd be undefined. I show you this picture. I show you how these are derived for this following reason. If on an exam you don't get your cheat sheet and you need to figure out from a rectangular to polar, how do you do it? Well, just draw the picture. And you have a triangle. Oh, okay, I can use the triangle. X squared plus y squared is r squared, or tangent of theta is y over x. That way, if you don't have the formulas on your cheat sheet, or if you don't have a cheat sheet, you're still able to solve the problem. All right, let's look at some examples. So the first one, we're going to go from polar to rectangle. We want to convert the point P 2 pi over 3 to rectangular coordinates. So the first thing I would do is try to draw this point so that you can see where it ends up if you had an xy system. So let's say we have our xy coordinates, but from polar, if our origin is here, what do we have? 2 pi over 3 and a distance of 4. So this is where my point lies in the rectangular coordinate system. The question then is, for my x and y values, what should I get? Well, I better end up with x is negative and y is positive. If I go through the math, if I follow these formulas and x is not negative and y is not positive, I've got some trouble on my hands. So let's figure that out. So first, our x, using the formula, is r times cosine of theta. So x is r, which is 4. Cosine of theta is what? It's cosine of 2 pi over 3. So this is 4 times, what's 2 pi over 3? It's negative 1/2. So 4 times negative 1/2 is negative 2. So that's my x value. That's good. I expected my x to be negative. Same idea for y. Y is r sine of theta. So that's 4 times sine of, so r sine of theta, so r sine of, so 4, let me start over. So we have y is equal to r sine of theta. So that means y is equal to 4 times sine of 2 pi over 3. So that's 4 times, well, 2 pi over 3 is square root of 3 over 2. So the 2 cancels with 4, gives me 2, so I get 2 times square root of 3. So converting that to rectangular coordinates, my values would be -2 and then +2 square root of 3. All right, what if we want to go the other way? So for the next example, we're given rectangular coordinates, and I want to find what's my value for r and theta. So we want to convert the point 2, -2 to polar. So again, let's draw the picture. So 2, -2 is where? It's 2, -2. So I want to find the polar coordinates for that point there. So first off, I need my r. And I know r squared is x squared plus y squared. So r squared is 2 squared plus -2 squared, which is 4 plus 4, which is 8. That's my r squared. So r is the square root of 8, which is the same as 2 times square root of 2. So my radius is 2 square root of 2. Now I need my theta. So tangent of theta is y over x. So tangent of theta is -2 over +2, which is -1. So I know I'm in quadrant 4, so where is tangent equal to -1 in quadrant 4? So this means my theta is minus pi over 4. And again, that's why we want to sketch these points, because tangent is -1 where? Tangent is -1 here and also in quadrant 2. But if I put it in quadrant 2, I'm not ending up at the point where I started. So I have to have my value -pi over 4 to get me into quadrant 4. So that means in polar coordinates, this is just equal to 2 square root of 2 and then minus pi over 4. All right, so I'm going to erase that. We'll look at another kind of example here. So in these last two examples, they were pretty straightforward. We're given polar coordinates, we want the xy value, we just plug them in the formula. Or we're given rectangular coordinates, and we want the polar, so we just plug them into the formula. The next example we're going to look at is an equation. So we're given an equation in rectangular coordinates. X squared is equal to 4y. But we want this equation in terms of polar coordinates. So the first thing we're going to do, because we want polar coordinates, is we're going to substitute the values that we had from those equations. So our equation for x said what? X is equal to r cosine of theta. So I'm going to plug that in here. R cosine of theta. And because it's squared, I leave that there. So this thing is still x squared, It's just written with polar coordinates now instead of the x's and the y's. And then over here, what do I get? Well, y is equal to r sine of theta. That's not squared, so I just write that within the parentheses. So now, this side here I need to simplify. Because they're multiplied together, I can just bring the squared piece in. So over here I have r squared cosine squared of theta is equal to 4 times r times sine of theta. So I'll try to figure out the r value first. So what do? I divide both sides by cosine squared. Because I have r squared here, what can I do? I can divide by an r here, and that means that squared cancels. I'm left with just this r here, and these cosine squares cancel. So on the left side, I've canceled everything out except for one r. So I have to do the same thing over here, r cosine squared of theta. So here, the r's cancel out, and I'm left with 4 sine of theta over cosine squared of theta. So remember, we're not going to end up with our p r theta. We have an equation. So ultimately we want an equation that says r is equal to something of theta. So whatever value we have, whether we have r, whether we have theta, we can plug that value in and figure out what the values are. So here I'm going to simplify. If you remember from when we were doing the simplification of the trig expressions, I'm going to do the same thing here. So I have 4 sine of theta, and in the denominator I have a cosine squared. So I have cosine of theta times cosine of theta. And if I look at these as 3 separate pieces, what do I get? I get 4 over 1 is 4. Sine over cosine is tangent. So tangent of theta. And then this one is like 1 over cosine. 1 over cosine is what? It's secant of theta. So the original equation I had was in rectangular coordinates. If I pick some value for x, I can figure out what the y value is. If I pick some value for y, I can figure out what the x value is. Now I've rewritten the equation in polar coordinates so that if I have some value of r, I can figure out theta. Or if I'm given some value of theta, I can figure out r. So that's my equation. R is equal to 4 tangent theta secant of theta. So a rectangular coordinate equation written in terms of polar coordinates. All right, let's look at another one like that. So I'm going to erase this. If you need to pause it, kind of backtrack through, that's fine. All right, so this next problem we want to express in rectangular coordinates and graph, if possible. So the first problem we have is r is equal to 5 secant of theta. So this is the reverse of what the problem we just did. Last problem we were given rectangle, we want to convert it to polar. Now we're given a polar and we want to convert it back to rectangular. So first thing we're going to do is secant is what? This is 1 over cosine of theta. If I want to get rid of the cosine of theta in the denominator here, what do I have to do? Well, I have to multiply both sides by cosine of theta. So when I do that, the cosine of theta cancel each other on the right, so I just get 5. And on the left I have what? Cosine of theta is equal to r, which I can rewrite as r cosine of theta. So if I'm going from, so that's another little trick you can try, is that if you didn't want to cancel this out over here, ultimately if we're trying to convert this to x's and y's for our equation, we need to try to have these r cosine of theta or r sine of theta. Because now this guy here, r cosine of theta is equal to what? That's just equal to x. So this r is equal to 5 secant of theta is the same thing as saying in the rectangular coordinate system, x equals 5. And how do I graph x equals 5? Well, I have my rectangular coordinate system, so x equals 5 is just this dotted line here. Vertical line, 5 units out along the x-axis. So that's it for that one, example number 1. So example 2, we have r is equal to 2 sine of theta. So again, remember what I just said is we want to try to generate r cosine of theta or r sine of theta. That way it will at least give us our x's and y's that we can change out. So if I want r sine of theta, it means what? I have to multiply this side by r. So if I multiply that side by r, I also need to multiply the left side by r. So I get what? R squared is 2 times r times sine of theta. So now I actually can change this piece to x's and y's, and I can also change this one, right? Because r squared, in terms of the 4 equations I had, is what? It's x squared plus y squared. And 2 stays here, and r sine of theta is equal to y. So now if I want to move this 2y over, I get x squared plus y squared minus 2y equals 0. So this is starting to look like what? If I have an equation with an x squared and a y squared in it, that's the equation of a circle. But because I have this little extra piece, all it does is it means it moves the center of the circle, remember? So what do I have to do? I need to complete the square on this piece. So if I say that b is minus 2, 1/2 of b is minus 1, so 1/2 of b, and if I square that whole value, is positive 1. So I want to add a 1 in here, but because I added a 1 on the left, I also need to add a 1 on the right. So now I get x squared plus, this thing can be rewritten as y minus 1 squared, all equals 1. And so now hopefully this looks like the equation of a circle to you. And when I have this equation, it's the equation of a circle, I have what? The center is at 0, and then opposite of what I see. So 0, 1. And the radius is what? The radius is the square root of the value on the other side. So square root of 1, which is just 1. This problem asks me to graph. So it's a circle. The center is at 0, 1, which is here. And then the radius is 1. So 1 unit to the right, 1 unit up, 1 unit to the left, 1 unit down. Gives me a circle that looks like that. So that's the end of the videos for 8.1. We had our introduction in the first video of what the polar coordinate system is. And then in video 2, we started tying it back to what we know, the rectangular coordinate system. So how do we go from one to the other? And then how do we convert equations from one to the other, graphing them if possible. So that's it. We'll see you guys in 8.2.